Hi everyone, Daniel from Homegrown, Melbourne, Australia. So this is part two of my electronic brewery build for CraftBeerPi. So in part one, we looked at establishing a DS18B20 temperature sensor, and you can see that 18.5 degrees here on our screen for our HLT. And we established the ability to demonstrate that we could turn on and off a GPIO pin on the Raspberry Pi, basically based on the temperature. So if I turn this on here, you can see that this HLT heater turns on also, and effectively that's configured back to a pin here on this board. In this case, I use GPIO pin 21, and that triggered the LED to turn on, or created a circuit to turn the LED on. So that told me I could basically use the software to control the board. And if I then take my temperature sensor, my little DS18B20, and stick it in some hot water, basically we see the temperature rise from 18 to 21 to 47 to 60, and it's turned off the element. So I'll take that out and let that cool down again, and we'll see that come on at some stage during the video. So that was part one. So part two, we're going to introduce a relay board, and these are small relays, not designed to take large currents for a long period of time. So we wouldn't be triggering our heating elements with these, but we could certainly use them to trigger pumps, or potentially turn off valves, things like that. So I've bought a HW316 board. I got this from Core Electronics here in Australia, in New South Wales, from their website, along with a whole bunch of other things. And they're relatively cheap, you know, in the order of $10. And so I thought that's great to sort of start testing this out. So basically what I've done is connected these two pins here that have a jumper connector on. That yellow jumper connector was on there. And I've connected the VCC back to the 3.3 volts and the JD VCC back to the 5 volts on the Raspberry Pi. You remember I've got this GPIO extension board connected back to my Raspberry Pi here, which is running the CraftBeerPi software. From there, we've also got the ground pin. Makes it easier to read. We've got the ground pin connected back to our ground rail on our breadboard. The ground rail's connected by this cable here back to ground on the GPIO extension board. And we've got this input 4 for relay 4 connected back to GPIO 6. So how does that work back here? If I go into System, Hardware Settings, where we can figure up these devices, and then I'm looking for that hot water pump, you can see here I've got it configured not as a GPIO simple, I've got it configured as a relay board. Now, if you don't configure it as a relay board, you get the opposite effect to what you actually desire. So when it's turned on, the relay will be turned off. So you've got to configure it as a relay board. And I've got it set to GPIO pin, which is what we saw back, our wire going from input 4 on the relay board back to GPIO 6. So basically we've got that configured up nicely, all set up ready to go. If I go into brewing and I select that hot water pump, you would have just heard a little click then, and you can see this LED here has turned on. So I haven't got the other side of the relay board connected to anything yet, but I know it's working because that LED's come on and we heard that nice switching clicking noise, which is the magnetic coil basically attracting the contact to close and create a closed circuit. So that's basically how I've connected the relay board. So I know now I can turn pumps on and off using this kind of method. So this is really just me prototyping at this stage, making sure I understand exactly how it works, and I can build a target state board to use in my home brewery. Hope you found that interesting. I'm going to continue to take us on the journey. So my next part 3 will be on the Darlington transistors to trigger solid state relays, and we'll talk about more about that in part 3. Thanks for watching, and if you'd like to watch more of these, please feel free to subscribe. Cheers for now, bye.